Alright, so example 8 says we use the following formula to find the derivative of the last section, provide a geometric interpretation of this particular bit. So I'm going to start by, drawing a picture. Alright, so there's my x-axis, there's my y-axis, that's nifty. Alright, so let's say that this here is my graphs, just for shiggles. And let's call this x, which means that it would cross that particular graph right there. And then let's say that I've got a distance of h somewhere, so then I would have another coordinate here that would just be x plus h, because I'd have my original x plus whatever distance this is to get to that particular coordinate. Alright, so then my point on the graph would be clear up there. Alright, so I've got some function that I plugged x into, so my y-coordinate should just be f of x. Likewise, my y-coordinate for this particular point should be about here, not down there. Oops. Alright, so it should be about there, should be my y-coordinate. So if I plugged in f of x plus h, that's just going to be my y-coordinate. And this whole idea is that my h is going to be getting closer and closer and closer as time goes on. So each time I'm going to be drawing, so as h is getting closer and closer and closer, I keep drawing this tangent line, and then I would have, it would let me, so as h is getting closer, my tangent line becomes less and less steep, I guess, as you could say in this particular, but that's just in this particular graph, as h gets closer and closer and closer. Alright, so let's try a third way. So we need to draw a picture representing this particular formula. So again, start by drawing my x and my y axis, and then I'm just going to draw my graph. So this time, I'm still going to have that x sitting there, and then I'm going to have my distance of h. So then I would have an x plus an h. If I went h degrees, not really degrees, but h distance away. But what if I go h distance back the other way? Well, if I went h distance back the other way, then I would have x minus h sitting over here, which, well, an h and an h, that gives me that 2h in that particular formula, in that denominator. So that's where that comes from. Alright, and then if I were to figure out what this y-coordinate is, well, plugging it into my function, I would just get f of x minus h, and then I would get f of x here, and then plugging my x plus h into my f function, I would just get f of x plus h. Alright, so the whole idea here is I'm just looking at f of x plus h and f of x minus h. So I'm just looking at these 2 points right now, and I'm drawing my tangent line. Well, that's cool. But I'm still wanting h to approach 0, which means that the distance in between x minus h and h plus x and x is going to get closer and closer and closer, going from both directions. That's all this one does. Oops, I probably should pick it right. So I'm just going to get closer and closer and closer to that point from both sides in this case. So the whole idea here is that my secant line in this case becomes my tangent line. That is the main difference, is we are trying to make these be tangent lines. And that's about the only defining difference. I honestly will probably use this one the majority of the time. I'm talking 99% of the time. The other part that I might use that one is if I'm specifically told I have to. But I seldom see this particular version. I'm not saying it doesn't get used, but I'm saying it's a lot less common. Alright,